Differential equations 2, first lesson, first order differential equations, second part of the lesson, separable equations. Consider a differential equation in differential form m xy dx plus nxy dy. So mxy dx nxy dy, where mxy is ax, right, function of x, and nxy equals by, function of y. It means this part is function of x, ax times dx. This part is function of y, by times dy plus equals 0. If a given equation in we can create in that form, it means the differential equation is a separable or its variable separated. So then we can get that as a separable equation. So we will do an example, right? Y dash equals x plus 1 over y is, right? That is easy one. So you can write y dash, you know that y dash you can write dy by dx equals x plus 1 over y to the power 4 plus 1, right? So then I am do the cross multiplication, y to the power 4 plus 1 times dy equals x plus 1 times dx. So I can take this for that side. So x plus 1 times dx minus y to the power 4 plus dy equals 0. So then this is in that form, no? Ax dx plus by dy equals 0. X, function of x times dx minus function of y times dy equals 0. Then that means this is a separable equation. This is a separable equation of the form is m x comma y dx plus n x comma y dy equals 0. So then we can integrate this one, integration x plus 1 dx minus integration y to the power 4 plus 1 dy equals 0. So we can separately integrate x times dx plus dx here minus y to the power 4 dy here also minus dy equals 0. Then we can write x square over 2 plus x minus y to the power 5 over 2, sorry, not 2, y to the power 5 over 5 here minus y, then plus c equals 0, where c is an arbitrary constant. Next type is homogeneous equations. A differential equation in the standard form. Standard form is dy by dx equals fx comma y. If homogeneous, if tx comma ty equals fx comma y for every real number t. So this is the condition. So if a homogeneous differential equations can be transformed into a separable equation by making the substitution. If you found a if you found a homogeneous equation, so you have to substitute y equal x comma xv, so then you can convert this homogeneous equation into a separable equation, and you can solve this along with the corresponding derivative of this one. Dy by dx equals v times dx means 1. So you can, if you derivate this, you can take this answer. The resulting equation in variable v and x is solved as a separable equation. The required solution is obtained by the back substitution, right? So we will do an example. Y dash equals y plus x over x. So y dash means this we can write in the standard form, f x comma y equals y plus x over x. To check whether it is a homogeneous equation or not, we have to substitute tx and ty where t is a real number, right? So we need to find f of tx and ty, no? Tx comma ty. So instead of y we need to write ty, plus instead of x we need to write tx over tx. Here y ty, t is common, y plus x over tx. You can cancel t and t, then it's remaining y plus x over x, y plus over x, y plus over x. It means this one, no? F x comma y. Then condition is satisfied here. F tx ty equals fx comma y. It means this is a homogeneous equation. So you can write, therefore the equation is homogeneous. That is homogeneous. So if it is homogeneous, what we have to do, we have to substitute this one, y equals xv. So substituting y equals xv, so we can differentiate this. Then we can take dy by dx equals v plus x times dv by dx, right? Then I'm consider this this equation as 1. Then by 1 you can write y dash means dy by dx equals dy by dx equals y plus x over x. So dy by dx we found v plus x times dv over dx equals instead of y we have to put xv, because y equals xv, plus x over x. So you can divide by x, then here remaining v plus x times dv over dx equals, here cancel, that v plus 1, then v and v also cancel, then x over dv over dx equals 1. So we can subject dv, then 1 over x times dx. So you can integrate this one. So then v equals 1 over x means ln x plus c, where c is an arbitrary constant. And we can substitute v, so we get y equals vx. It means v means y divided by x. Instead of v we can write y divided by x equals ln x plus, instead of c I am writing ln k, where instead of c, no, c equals ln k. I substitute ln k instead of c. So then we can write y over x. Ln addition means we can write multiplication, ln x comma y, sorry, not y, but we get k, no, x comma k, x comma k. So we can subject y, then x times ln kx. This is the answer. And next type is exact differential equations. A differential equation in the form mx comma y dx plus nx comma y dy equals 0 is exact if there exists a function gx comma y such that dgx comma y equals m x comma y dx plus nx comma y dy. For exactness, this is a test for the exactness, dm da by m x comma y over da by y equals da by n x comma y over da by x. We will do an example. We can take example 6x plus y square dx plus y times 2x minus 3y dy equals 0. This is the example. So first this is the form of this one, this form mx comma y dx, and it's that differential form. The equation is in the differential form, that's correct. Then we have to select m. M means this part here. M is this part now. So m we can take, instead of without dx we can take m. So m means 6x, m is 6x plus y square, then n is this part, y times 2x minus 3y. So we can remove the brackets, then n we can take 2xy minus 3y square. So test for exactness is da by m over da by y and da by n over da by x. So da by m over da by y, da by m over da by y. So we can here x, here y, subject is y, so this is 0, that x is constant, then plus 2y, answer is 2y. And we can find da by n over da by x also. Here y is a constant, then 2y multiplied by 1, sub y is a constant 0, then 2y. So it means therefore da by m over da by y equals da by n over da by x. What happened then? If these two are equal, then according to the concept, that is an exact equation. So therefore we can write this is an exact equation. This is an exact equation, and we can write the solution also. Solution is if x comma y equals c, where c is an arbitrary constant. Right. So then we need to find the answer, that's fx x comma y equals c. So I am writing then this one, da by f over da by x. I selected that m equals 6x plus y square. This is the first equation, and also da by f over da by y, that is n means this one, 2xy minus 3y square, second equation. So so then I am taking 1 is this one, no, da by f over da by x equals 6x plus y square. I am integrating, so by integrating we can take integration da by f equals integration 6x plus y square da by x. I can integrate, here comes f equals 6 times x da by x plus y square times da by x. So f equals here 6 x square over 2 plus y times x plus constant. That constant is a function of y, so we can write that is f of y, that is function of y. This is the third equation. Sorry, we can write that f of y, that is f of y, that is f of y, that is function of y. So we can simplify further. F equals 3x square plus xy square plus f of y, that is the third equation. So y, f of y is a constant, and that is function of y. So we need to determine fy. So to determine f of y, so we are going to differentiate this third equation with respect to y. So we can write differentiate with respect to y. Then differentiate, then we can write da by f over da by y equals, here no y terms, it means this is a constant, 0 plus x is a constant times 2y plus, if we differentiate f of y from y, that's come f dash y. So we can write da by f over da by y equals 2xy plus f dash y. This is the fourth equation. So second, da by f over da by y. Here da by f over da by y, it means second and equation are two, second and fourth equation are equal, so we can write 2 equals 4. So here second equation is 2xy minus 3y square equals this one, 2xy plus f dash y. So you can remove 2xy and 2xy. So here we can write then f dash y equals minus 3y square. So we got f dash y equals minus 3y square. So to find f of y, integrating with respect to y. So integration f dash y equals minus 3 integration y to the power 2 da by y. Y to the power 2 da by y. So if you integrate f dash y, it's come f of y equals minus 3 times y cube over 3. Then it's cancelled. Then f of y is equals y cube minus, that's come minus y cube. So then we can write the answer by third equation, this one. Instead of f of y, we can write found value 3x square plus xy square. So by 3, so we can write f equals 3x square plus xy square. Instead of f of y, we can write y cube. So therefore we can write 3x square plus xy square minus y cube equals constant, not c, that is c, where c is an arbitrary constant. This is a way of solving exact equation. That is all about the lesson number 1, first order differential, ordinary differential equation. I think you can understand this lesson, and based on this lesson you have a tutorial. So do that tutorial within given time, and if you have any problem, contact me, then I can help you. Then thank you very much.